Well, hello there. How's it going, my peeps? Two videos in one day, you say? Yeah, well, I'm not trying to do a lot of editing. I just like to throw my stuff up and go real time. It kind of makes it, I don't know, more real, probably. But I got to thinking, whatever happened to M. Benz? Well, went to look up his channel. Looks like he has no content. Now, he's got 825 subscribers, but no content. He's got channels. He's got discussions. Last thing he said was a year ago, according to this. No, it wasn't even him. Just discussions here. 1 year ago was the oldest. Rob Ashton, who's apparently mocking him with, well, let's hope we get some globe believers down in the comments. And then, in parentheses and italic, disables comments to his tired people mocking his 5-year-old's grasp of science. Having perused a number of your videos, I have to confess that I'm utterly flabbergasted at the level of stupidity you're operating on. You need to understand what the rules are before you seek to disprove them. A step in the process you have clearly missed out. You're so dense, I'm surprised that you don't generate your own gravitational field. Go back to school, get way out of your depth, and if you really want to see an experiment that proves water can defy gravity, simply walk in your kitchen and switch the kettle on. That stuff that comes out of the spout as it boils is water, defying gravity right before your eyes, you fool. So he got a lot of ridicule. So I'm guessing that it's hard to even say when he was here before. I'm guessing that he got sick of it, and in an effort to probably find some peace of mind in his own life, he was like, nah. And this is an example of what the flat Earth really is. It's a swell, whoosh, and then it's an ebb and a flow. Really, that's what it is. And it left. It's also a neat, so it split. It's splitting. It's really failing in a lot of its ways, and I just kind of wanted to pop in here and do some more elementary drawing. But I have a point to make, and that's why I fired up my OBS again here. And here's my point. Whenever you're trying to engage with people in any scenario, and it doesn't have to be flat Earth, it can be literally any forum in which there is any kind of information that may or may not may not defy what somebody might consider current knowledge. And I think if we use the flat Earth as a context on this, it's pretty simple, straightforward. Most people are out here presenting halfway. Most people are out here presenting a scenario in life that is very different from what they taught you in school. Your flat earthers are sitting here trying to essentially evade science and circumvent it with a belief system that relies heavily upon ridicule, insults, questions, and explanations that defy all that has been documented. And what you don't find any of is an actual experiment or demonstration that takes away any doubt and completely matches reality at the same time. So I just wanted to make the point to you flat earthers as you're out there doing your thing. This is what a claim that a genuine person seeking to sway an argument does. And it works like this. They say something. The relation of a triangle, the relation to a triangle's hypotenuse is equal to the length of the side squared and then added together. So in other words, a squared plus b squared equals c squared. Now, this is math. And maybe at some point Pythagoras had a lot of ridicule, okay? And at some point, he had to go out and say, fine, you don't believe me? Watch this. And I'm trying to make as best, this is not exactly a right triangle, I'm just trying to do my best. And this is definitely not going to be straight. Well, let's just end it, let's just do it like that. So he said that if you take the side A and the side B and the side C and label them as such, and you square the length of this side, and you square the length of this side, then it will equal the length of this side, the hypotenuse. And it's called the hypotenuse because it connects the sides, right? There's probably actually more to it than that. And I would guess that there's somebody out there who had something to do with naming that side. But the actual reason behind this is why he proved it, why he says it's true, is based off of squares, right? Because what a right triangle is a square cut in half diagonally, right? So you get two right triangles, because this is conceivably a square. And the idea is that this is the same as this, is the same as this, is the same as this. And if you were to square that and that, these also should become the same. Which is to say, if you take two sides and square them, then you get a square like that. And this distance in the middle would then follow that it is both of, it is the square of this, the square of that, plus the square of this and the square of this added together to create that. That was the I'm probably missing out on the actual definition, but that's the basis of the Pythagorean theorem was actually the square, cutting it in half and taking it from there. At this point, I will show you what I mean. So we're going to use actual numbers, and we know that that's 5. How do we know that's true? Because 3 squared plus 4 squared equals 5 squared. If you factor these out, you get 9 plus 16 equals 25. This is a true statement. This is what proof looks like. This is what somebody giving proof looks like. And to just drive that point home, can I not select all and delete? Oh, I hit the wrong button. Give me a sec. And pow. Sweet. I make an observation. Oh, I need a pencil. Okay, leave that out of there. Give me my pencil back. I 1. Make my observation. And then 2, I decide, because of this observation, I'm going to make a hypothesis, not to be confused with hypotenuse. My hypothesis is not the same as my hypotenuse. And then I want to do some work. I'm not drawing right. Do some, you all remember cursive? Do some work. What that looks like is collect data, either by observing it and recording it, recording your conditions, recording your experimental conditions, recording all the controls that are in place and the implements used, and putting them together, and then taking that data and looking at it and analyzing it. So you do a little analysis, which yes does have the word anal in it, which by the way is where anal comes from. It's the root of something probably. Probably something that most of us don't want to know about. Just kidding. It does probably have a root in there. But anyway, so you do your analysis, and from your analysis you draw a conclusion. Oops. Conclusion. You guys get to see my shitty handwriting. It's pretty much the same on paper as well. Okay, now once we have a conclusion, what happens is we create a model most of the time. model. And this is the key aspect of what all this is, because this model represents this and then explains why this was either A, correct, or incorrect. So you see all of this happens, and then you have something called proof. But in science, remember, we don't really prove things for the sake of proving it, and it's not really proof from the standpoint of proof. But what it is a conclusion drawn, conclusion from the data, well, from the analysis of data. You know what? I spelled that wrong. I'm an idiot. A-N-A-L-Y-S-I-S. Of data. And then other people look at it and they concur. And then what ends up happening when all of that is in place is we have either a law or a theory or any number of things where we can use that thing, that model. And the purpose of the model isn't necessarily to have a model, it's to be able to make predictions. Do you think science has been accurate about the Earth so far? Well, these models have been used to do news reports, which I must say, from the time I was a kid until now, have improved remarkably. Very big. They've been used to create GPS. That's the globe model, right? They've been used to create flight paths. And entire airlines use on a daily basis to go from point A to point B. These models have been used to understand ground zeros of things like virus outbreaks, and then they help you to understand containment and how to do it. Relevant today. They help you understand probability. What's the probability of dying from this virus? What's the probability of dying in an airplane? What's the probability that the precipitation is going to occur based on blah blah blah? Probability is also used every day in regular business, like casinos, right? Their whole business is literally probabilities, which are based on absolute modeling. And some of the examples of modeling can be any kind of sample, but like rolling a dice. What are the odds that you will roll a 1? If you roll if you roll one die, you roll it twice. What's the probability that it will roll a 1 both times? That's actually really easy. There's a model to figure that out, but it goes like this. And this is how simple a model is. On one roll, the chances are 1 in 6 that you're going to land on a 6. If you roll it more than that, you now start changing the model a little bit. And it looks like this. So how do we simplify that? Our model is how many favorable outcomes versus over divided by how many possible outcomes to the nth power, where n equals number of rolls. That is a model in probability of rolling dice. So probability in casinos makes people money and gets people paid so they can pay their rent. It's the same with drawing cards and what's the probabilities of blah blah blah. And the casino know these probabilities because of models that have been created, because of math, because people sat down and had a thought and were able to like flesh it out. So do you see what I'm saying, flat earthers? It's not enough to just say. And this is your whole flat earth argument right here. This is your flat earth argument. Somebody literally said to me tonight in a comment on another channel, Nathan Oakley's channel, I believe, that I don't want to directly quote him, but I'm going to, because I think this is what he said in a nutshell. the Earth should curve like it does in sci-fi movies. It doesn't, though. I want you as a flat earther to think about that for a second. Here's the basis of this argument. Someone's imagination. That's actually it. Someone's imagination. That is the basis for this comment. Somebody wrote a script, sent somebody into space on a vessel that took off from Earth. As it went up, the Earth was seriously curved. Okay, cool. Does that match reality? No. So what is the point of that? Your argument should match reality. That's the number one thing about things that you say. It should match reality. If it doesn't match reality, and you know something else to be true, like gravity, if you think gravity is a thing, and something defies that from a scientific perspective, your question should be, why? Why does it defy gravity? So for an example, if you have a helium molecule, I'm just going to do that because I don't actually know what they look like. I could look it up. I don't want to. You'll get the point. And then I have a water molecule, which I know happens to be a little Mickey Mouse. 3 molecules, and 2 of hydrogen and 1 of oxygen, right? H2O. Chemical makeup. And then helium, I believe, is just H1, right? Just one element of helium. Okay, so the mass of these two things, the atomic mass, is different, which means there's an atomic mass might actually refer to a different mass or something, but just looking at these two things, knowing how gravity works, this is going to go that way. Why does that go that way? This is one of those questions. So you ask yourself, why? Now, flat earthers, you go right on to, let's bypass that and say, well, I guess there is no gravity because everything goes down and helium goes up, so no gravity. Okay, is that complete? Most of you, yes, they think it is. It's not complete. Because if we know gravity to be true, and we can predict it with an equation, why is there this one little happy molecule over here, little Henry, deciding to go this way? Woo! So we have to figure out why. Now, we can consider that buoyancy, right? So what causes buoyancy? Now we have an entire experiment to perform because something defies our understanding. And rather than give up and just come to some ridiculous conclusion that has no basis, we do some research into stuff using things at scale that we can use. And what we understand about the way molecules will accumulate is that everything accumulates downward toward Earth on the surface. And those things that can't get to the surface because they're not dense enough, they stack on top of one another. And since air molecules are heavier than helium molecules, they're the ones who take up this space down here. And yes, while helium is trying to get to Earth, it can't because these other molecules are finding their way under it. So it literally, in a very rapid succession, looks like this, where these molecules are taking the space and helium is just trying to get out of it and keeps floating up until it finds its equilibrium. And helium will stop. It will reach a point in the sky where it just stops moving. And that point is where its density matches the density of the things right around it. And then things that are lighter than helium, if there is such a thing, continue to stack on top of it. We tested this. That's how we know how buoyancy works. So given that, we were able to figure out how to create a submarine situation. It's the Hunt for Red October. The submarine situation has these little chutes that they can use to increase and decrease their buoyancy. I don't know if they're chutes. They're ways of releasing, they're creating less density or more buoyancy by adding mass to a certain section of it. And then they can say, I want to go from 200 knots below the surface. That's probably the wrong thing. I want to go from 200 units of measure up or down to 250. And without any effort whatsoever, because of all the research, they go right up here to 150 quickly and easily. Because they know how to use science and technology to do that. Now, how do we know how to do that? And see, that's where I get so frustrated and want to call you guys dipshits and nimrods, because all of this data exists. Let me show you how easy it is to find this data and make a point. As you can see, everything that I'm doing right now is showing you evidence or talking about a model or showing you in some realistic way to explain the globe Earth model. No, how about this? How did we figure out how to maneuver submarines up and down? I don't know. I haven't done this search before. Diving and surfacing. Okay, here we go. Let's just look at the first. This first. Well, that's how stuff works. Maritime. Excuse me. Just read a little bit here. These terms arose with the building of the first. Submarine is in light condition when all of its water ballast tanks are empty and its cruising bridge rig. So it sounds like they can open up doors and take on water to sink and then to release water in order for buoyancy. I'm not going to edit out my costs. I'm just going to apologize for them. Okay. Let's go to how stuff works. It's a little bit of a breakdown. But this is just one website, and I encourage you to, if you really care, you want to figure out how all this acts, to really dive into it. But here's an example of how you can figure out stuff. To control its buoyancy, the submarine has ballast tanks and auxiliary or trim tanks that can be alternately filled with water or air. Pretty much sums it up. That's exactly what I was thinking, but they figured that out. Okay, when submarines on the surface, the ballast tanks are filled with air, and with the submarine, overall density is less than that of the surrounding water. As the submarine dives, the ballast tanks are flooded with water, and the air in the ballast tanks is vented from the submarine until its overall density is greater than the surrounding water, and the submarine begins to sink. Supply of compressed air is maintained aboard the submarine in air flasks for life support and for use with the ballast tanks. In addition, the submarine has movable sets of short wings called hydroplanes on the stern that help to control the angle of the dive. The hydroplanes are angled so that the water moves over the stern, which forces the stern upward. Therefore, the submarine is angled downward. So, see, they've actually done, studies on how stuff works. It probably wasn't that hard. I have to say that every time I do a video, that's when I cough. I never really do one when I'm not coughing. Okay, hold on. Okay. God Alright, so anyway, it's real simple to just do some research. Now, here's the real cool thing. You could, as a flat earther, just go, okay, I don't believe in this, so I'm going to test it out. I'm going to go get a bucket, and I'm going to fill it with water, and take water out of it and see what happens. Because that's essentially what's happening. Or whatever, or make a controlled environment where you're taking, like, a tube and seal it off, but create little, glue together some other portion of another tube onto the side of this tube that can fill with water, and fill it with water and see what happens. And what I imagine is you'll probably figure out how they make submarines work. Now, this isn't about submarines, and it's not about buoyancy and density. It's really about how do we actually come to a conclusion on something. And it's never by watching videos. That's typically the starting point. And all of you flat earthers are at starting points. You're not even at a point where you're ready to make any kind of determination, because you can't even do this much. You can't even tell me what the area of a circle is. You don't know. What the diameter is. You don't know what that. You don't know what any of this is. All you do is talk crap. Some of you have dived into the science, but you don't believe any of it because, quite simply, you're not trying. I don't like that. How about old school? I'll do this old school. This is my message to you. You're not trying. You're not trying. Could you do me a favor and start trying, please?